Cool. Welcome, everybody. It's really great to be back at Scala Days, and I hope everybody's enjoying the show, and thank you for attending the talk. So this is going to be kind of an interactive talk. We're going to engage with you, so hopefully it's going to be fun. And, you know, just to kill it, there's like, who thinks their build is too slow? Raise your hands. Good. I like that. Everybody. Yes, I'm not alone.
There was someone who didn't raise their hand. I want to talk to them afterwards.
Cool. So today's topic is really going to be about X-raying your build. And the whole idea is that giving you what you need in order to understand what's happening. And then with that, essentially, we can optimize our build and squeeze out all the performance that we need. I'm here at stage with Iulian. We both work at Gradle. And the first thing, I just want to clear it out. Okay, you guys are working at Gradle. What are you doing? Right? Yes, Gradle is the commercial company behind the Gradle build tool, but that's really a tiny bit of what we do. Most of the engineering at Gradle works on Gradle Enterprise. That is the DPE platform, and it gives you observability and acceleration tools for different build tools. So there is Gradle, of course, there is Maven, there is Bazel, and you and myself have joined Gradle to work on SPT, and this is really why we're here today. Enough about that. Let's talk about motivations. So let's talk about the agenda today. We're going to start with asking ourselves, okay, why? Why does this matter, right? And then the what is the observability data that we need? And then finally the how can we do that in SPT? So anyway, going back, so this is our life in production. We're used to have a ton of observability data, and that is super useful to see what where our services are, how are they behaving, and it helps us keep them on check, right? This is really the status quo. If anything isn't going as expected, and potentially even if we start seeing the symptoms of something not going in the right direction, we intervene, and this is thanks to the visibility that we have. This is our life in production, makes complete sense, great. So we don't go blind in production, right? And we know that we don't go blind in production because that would put the business at risk. We have advanced tools for that purpose. We're very lucky. It's a very crowded space, right? This one, there are so many options. And at the end of the day, we all get to benefit from that because we can pick the tool that actually best fit our needs or our personal taste. So we're engineers. We love data. We know that that's how you make effective decision-making, but we're still going blind when we are developing, right? It's like we have no idea about what's happening under the hood. Why? And what's at stake here is our productivity. And, you know, yeah, okay, it's like, does it matter? Well, yes, it matters. If you think about it, it's actually also business critical, right? Just like production. Productivity has an impact on the business, and we should just not accept the current status quo. So why does that impact the business? Well, think about time to market. It's all about fast iteration, getting our product out faster than the competition. But if we're slow, well, there's going to be somebody else coming in and going faster than we are. So I would argue that developers' productivity should really be a continued OKR for every company out there. Every company out there is a software company. Software is so centric everywhere, right? And I would say even more now, given the global economy in which we are. We're all being asked to do more with what we have. Well, in order to get there, we actually all need to be able to be more productive. So, as I mentioned, this is going to be an engaging talk. Everybody's going to participate. So, take out your phone, scan the QR code, and the question we're going to ask you is, how long does your PR check take? And I'll just put on screen, so you'll see that this is the question that you're going to get. You have a few options. Oh, yes. Yeah, I was too fast. Sorry, guys. And when you answer this question, don't think just about the time that it takes for your PR, let's say, for your CI to build your PR. But think about also if there is a queue, essentially, to get your PR to be building. How much time are you waiting? How much time are you context switching to something else? So let's see. We're starting to see some results. This is fun. Cool. I see we have a tough competition between 15 to 30 minutes and less than 15 minutes. But we definitely see that there are some people between 30 and 60, and yeah, some matter forever. I think I'm with the forever. Like, I know I go for lunch when I need to do that. It's like, that's where I am. Cool. Yeah, I think it's pretty clear. It's, some people are lucky, less than 15 minutes. But most of the rest of the population is more than 15 minutes. And that's a drag, right? It's enough of a context switch. Thank you, everybody, for playing the game. So, and while we wait, do we actually know what's happening in our project when we build? Do we understand where time is being spent? And why does it take so long? And finally, what can we do about it, right? It all boils about that. It's like, if we can't do anything about it, well, we have to accept it. But can we challenge the status quo and actually do something about it? It really boils down to that. So what we need is data. Without data, we're just doomed to accept whatever inefficiency come our way. Today it might take 10 minutes, well, it takes 10 minutes. Tomorrow it might take 30 minutes, well, it takes 30 minutes. We can't do anything about it. And if you look at the image in the middle, you don't have to look at all the details, but essentially what this image is trying to give you is a sense of how much time is it being spent initializing maybe your build. Think about SBT versus executing the task that you actually want your build to do. It also gives you very quickly an understanding of how much parallelization is happening at the build level. Are there any threads being blocked? What are the tasks being executed? How much time is it taking? And maybe possibly even, why is that task being executed, right? You start being able to challenge things about what's happening in your build. So what do we need? Well, we need the data. It's really just about that. So what is that we should be collecting? Well, there are a bunch of things. I'm going to spell out some of them. Of course, there are build tool data like the version, configuration parameters. You definitely want to capture the environment variables or the system, essentially, variables that could impact your build. That is the JVM version potentially, the heap that is being given to your build process. Of course, you want to know what are the dependencies of your build. And of course also console, output, task execution, because all of that is going to give you the tool to investigate and analyze what happened, right? And with this data, well, what we really can do is starting to challenge what we have. So we can start analyzing and debugging those problems. We can optimize then based on that data, right? We can spot those bottlenecks. And also we can track. We can actually see trends in our system. And potentially we can prevent bad things to happen in our system because we can make this tool, let's say, part of our quality gates. We shouldn't accept bad things to be introduced. Like we just don't accept, let's say, bad implementation when it's on a performance critical path, right? We're actually going to prevent that maybe through code reviews or by the means of testing, performance testing. We should just be applying the same level of scrutiny in our builds. So what do you need when a build fails on the CI but succeeds locally? And how often, or it definitely happened to me. It's like it worked on my machine, right? It's like, so what? And what do you do at that point? Well, again, I'll talk about me. It's my experience, but unless it's very evident the reason for the failure, let's say a compilation error because I didn't try to compile locally, and okay, that got me. But otherwise, well, if I know also that there might be some glitches in our systems, I might be probably just re-triggering the build, right? It's like, I'll keep doing whatever I was doing. I'm not going to be looking at that. I re-trigger the build. All of a sudden it fails again. Well, let's see, is it the same failure? If it's not the same failure, well, I know that maybe I've got some flakiness in our system. So I just keep re-triggering, right? Well, that clearly impacts my productivity as an individual. But it's not just about that. It impacts the productivity of everybody, right? The whole organization is lower as a result of that. Think about, your CI. You're going to be increasing load, right? So more PRs have to be built. And probably if your build is being flaky or is not passing, probably also the ones of the other people is not, right? So you're actually increasing load. And even if you have a very sophisticated CI where you spawn maybe nodes on demand so that you always have essentially the priority, well, that has a cost. So again, if you think about it, you link it back to the business, well, that is a real penalty that your business is feeling as a result of it. So what if we had a way to debug failures? What if I had something essentially so that my reaction wouldn't be, oh, I'll just retrigger the build, but I would actually try to understand what's happening. What would I need? I don't think we need very sophisticated tools there. I think the very first thing is a diffs on steroid, so that I could focus my attention on the difference between my local build and the CI build, right? Especially because I know what was the failure. I can see on the failure was maybe a test, right? Well, what can I do? Well, maybe I can see when was the first time this test has failed, or did it fail already in the past? So having these kind of tools would definitely make kind of a leap forward in my productivity. And instead of retriggering, I would actually spend the time, because it wouldn't take me much to just have a look and understand, okay, why is this failing? But it's not just about that. If I have such a tool, all of a sudden I can also investigate and spend some time understanding what's happening in my build, so I can identify bottlenecks. So what if I had, let's say, such a trace high level, right? Okay, what are the tasks being executed? What is the level of concurrency in my build? Is that what I expected or not? And it's very visual. I can immediately pinpoint if something doesn't look right. And in the end, as I was talking at the beginning, you want to track the evolution of your system. You want to be able to analyze failures across, not just on the punctual event, right? Because that is actually very important information. And if I can see how the system is evolving, I'm given a chance to avoid deteriorations in the system. So if you think about it, if we had such a tool, essentially our life during development would very much be close to the one that we have in production, right? It's pretty much the same tool, but tailored to our needs as developers. So in your experience, in your opinion, what is the biggest contributor to build times? And we're still going to be back playing the game. Very interested to see what is your experience? Maybe like this. How does that work?
You don't need to scan it every time, actually. It's the same link, so it just changes the poll question. But I think it can show.
Yep. Thank you, Iulian. Yep. All right. I see. We seem to have a winner. So, Iulian, what do you think about those results, and what is, in your experience, the biggest contributor?
Well, I absolutely agree with the results. Is this the point where we hand over?
Yes.
Okay. Thanks. Yeah, thanks for participating. So it's kind of a funny coincidence in numbers there. Of course, we had close to 80% of people saying tests are the slowest part of my build. In terms of how much of your build is really test execution, I've seen 80% as coming up in several places. So I would say in a large enough code base, perhaps not in a project that just started 3 months ago, clearly the vast majority of the time in your build is going to be test execution. So yeah, last question, I promise. What else is wrong with tests? Not just the time they take to execute, but what else can be wrong? Let me just go. Yes. Do that. It helps. It helps. Okay.
It's already done, nearly.
Did you vote, Mirco?
No.
So we have, oh wait, I'm not showing that. We have about 50 participants. I think before we had close to 70. Let's wait another 10 seconds or so. All right, so definitely the time seems to be the winner, but then there's flakiness as well. So I guess it compounds with how long they take. And if they also fail randomly or for no good reason, and the first, once you start trusting that they are flaky, you'll probably try a couple of times. So I've seen places or days in my work where I just retry a pull request maybe 3, 4, 5 times to make sure that all the tests pass. Of course, it's never my tests that are flaky. And how about we go about fixing those tests? And then we have a little problem, because I'm very biased. I will say my tests are not flaky at all. It happens once a month, but the other things are very flaky. So we need some numbers to be able to substantiate these claims and to go and say, hey, you guys, or we have to really start and fix those flaky tests. So if we had historical data, what Mirco kept saying, let's extract all the data we can, then we can answer these questions. What are the flaky tests and the flakiness score, how often they actually fail randomly? Then we can concentrate our efforts on the biggest, offenders. And I guess pragmatically, it's almost impossible, or I think it's impossible to remove all flakiness in any reasonably sized project or worth talking about. There will be some flakiness there. And in the end, flakiness can also come from the machine that runs the tests. It can be a node in AWS that just maybe has some transient network failure, and it still be a flaky test in that sense. We can't do much about it. But we should just focus on the ones that are really flaky and fix those. Another thing that's kind of useful is to identify patterns in failures. Sometimes you have failures that happen on one CI agent, like I mentioned before. Maybe the mitigation is just to restart that agent, or maybe they fail locally and pass on the CI, or the other way around. Sometimes they fail just for a single user. So if you have, let's say, 200 engineers in an organization, and there's just one person that keeps on getting failures on some test, you might want to ask that person, maybe you have some OS update that you shouldn't have upgraded to the latest macOS version. I don't know. And of course, tests are slow, so highlighting the slowest tests, which often are not always obvious, is a good outcome. All right, so all this is good and well, but we're using SBT. So can we get to this holy grail of observability and try to do some meaningful actions based on that? So if we take a step back, SBT is just a very generic task execution engine. So we can start with that. And it works with tasks that may depend on each other. And they become ready to run only when their predecessors or the task depends on is ready. SBT is parallel by default, so it will spawn as many threads as it needs to, which is nice. But we don't really know how many. So visualizing that is actually already available. So SBT has a command line option, traces. And here we can see very well that there is one bottleneck, compiling the tests before it can go on and start executing tests. But because we have two sub-projects, we have them being compiled in parallel. And lucky enough, they're pretty much the same size because they kind of start at the same time and end at the same time. There's some stuff happening early on, maybe dependency downloads or some other things that also happen in parallel. So we're pretty good. I guess maybe our test targets, if it's very large, we could break it in two to try to speed it up, but maybe we could just use Hydra on that, I don't know. If we wanted to have that resorted, we could also use timings, another command line argument, and we'd extract all the tasks that have run with their runtime. So we see that's about 1.5 seconds of compilation for the two projects we have inside. And tests are down here quite fast in this case. By the way, I haven't noticed that before I actually looked at the trace myself, that test suites are run by default in parallel in SBT. Each one becomes a task. So I have cache server suite, additional tests, and my test, and they all get executed in separate threads. That's great if you don't have any global state, I guess, being mutated by one of the tests. But that's neat. However, perhaps you would not expect it, but if you run your tests in a forked JVM, that's no longer the case. So they would be sequential. So the SBT execution trace is a great tool. It's easy to spot bottlenecks and try to reason about how can I parallelize my build more. And yeah, we all know the story. Today, it's only, we get more cores, but each core itself is not much faster than before. So that's an important aspect. However, just looking at the trace, we would not get any kind of failure analysis. We don't even know if those tasks have failed or succeeded. We just know how long they took. Maybe they were very fast because they failed. We also don't get any kind of logs, or any output is not saved. So as a consequence, failure analysis or test analysis, what we were talking earlier about, how can I find those flaky tests that are, really, it would be really great if I fix those, we need something else. So SBT actually has some built-in observability, some listeners that if you implement those in your build, you can start getting some events out of the execution engine. So there's only 2 of those, but they're quite important. So the progress reports, it's a setting where you can add a listener for task execution events, and that's essentially what is used by the visualization I just showed you, the traces that you can open up in Chrome. And there's a specific one for tests that looks a little bit different. The interface is kind of large, is big, but what you really care about is the 2 methods before and after work that give you a task and its result. So you can actually know if it failed or not, and you can save that. Perhaps all this data has to be serialized in some format and kept somewhere forever. Maybe you run Apache Spark on it afterwards to do your data analysis. And similarly for tests, we would get start at end event, and then inside them you could find some duration and the status or the test result. And again, you would have to extract this data, store it somewhere, make it available for analysis using some query engine, which could be whatever you want. So once we've done that, we would also like to go one step further. So we would like to speed up our build so we get to that productivity that we desire. And the fastest test is the one that doesn't run at all. And the answer to that is, let's cache results if we can. So build caching tries to be smart about your tasks, and expensive ones in particular, and not run them again if the inputs haven't changed. There's a little assumption in there. The task should be pure enough, so there shouldn't be side effects that you care about. So for example, you cannot cache clean, because clean should clean your output directory every time. But most tasks that are interesting are pure enough to burn. Of course, you will run into trouble at some point if you're not careful, but this can be done. And the other concern is that you will need enough storage and network bandwidth. This is a trade-off. You might need to download a lot of stuff from the cache and upload. And it's not always clear that it's faster to do that compared to recompiling some sources. Especially if you're on a network-constrained device, maybe you're at home working remotely, uploading a lot of stuff may not work very well. But Gradle does it, Maven does it, and Bazel does it. So how about SBT? Well, SBT does something as well out of the box. There is a very specific caching mechanism that is tuned or focused only on compilation. So only compiler artifacts are today cacheable. And the idea there is that you store the class files and some metadata that the incremental compiler needs to use in order to determine what needs to be recompiled later on. And the cache key is, I would say, correctly computed from sources, dependencies, compiler options, and so on, but it's not transparent. So caching happens when you actually call the push and pull command. So you can push to the remote cache and you can pull from the remote cache as a SBT user. You can set it up in your build, perhaps, or in your CI scripts to do that. But it's not going to happen transparently as it does for other build tools. And the second disadvantage is that this doesn't work for any other task. And we've seen that the tasks that we care about the most, or the slowest ones, are tests, unfortunately. But the Scala compiler is relatively slow, maybe compared to Java. Not so slow compared to other compilers, I would say, but anyway. And the other one is that you need a Maven repository where you push this thing. So it's kind of an interesting choice, but it works. So if you wanted to go a bit further and make this transparent, you could do it. You could redefine the compile task to automatically pull for you. And you could also push. I think here it's nice to be a bit smarter and only push if you actually compile something. And the incremental compiler will try to fight against you because the incremental compiler may do nothing, but from SBT's perspective, the compile task actually ran. So caching is almost a little bit done outside of the task system. The task runs always, it's just that it will incidentally do nothing because you already brought down the jars and the metadata. However, there's been a fair amount of discussion about the next major version of SBT 2.0, which I don't know. I think the Scala Center has very interesting plans for. And there is one proposal, RFC 1. I think it's a great number. And Eugene, whom you all know, describes a way to extend the caching mechanism to allow other tasks to participate, to declare inputs and outputs that are cacheable and hashable and so on, and maybe even allow different backends. I think many companies have more than one build tool and more than one language, so I think it would be great if there was just one cache server that could serve SBT and maybe also Bazel or Gradle builds. It's still in the early stages of design, but it looks very promising, and I think that that would be the killer feature for SBT 2.0. If that one works really well, I think it would bring a lot of benefit for large projects. So to conclude, developer productivity needs observability and caching. The good news is that all the ingredients are there for SBT today, or almost all of them. The bad news is that it's quite a fair bit of work to piece it all together. We didn't talk a lot about storage. How do all these events get extracted? How they get queried afterwards? And you need some UI on top of it. So incidentally, that's also what we're working on at Gradle Enterprise, and we'd be very happy to, if you came to the booth, to show you what we have and talk more about developer productivity and how SBT fits into that picture. Thank you very much. That's all we had, and happy to take questions.